Whenever you guys are ready, can you explain what you've built?
In our final project, we built a RISC-V five-stage pipeline processor with a testing framework and also visualization of some complex algorithm. And first, let me introduce our processing system. It's not only consists of a processor but also a test memory and source and sink. Memory is just where the data, the instructions data and also some data for these instructions stored, and the source is it can be so as some method to initialize the register files in the processor. And the sink is where we want to verify the results produced by the processor, and it supports these instructions, some register to immediate, memory jump branch instructions, this kind of. And this is our five-stage pipeline processor. It consists of the fetch, decode, execute, memory, and write back. And that is our memory. And this memory is communicated with the processor with many valid ready signals and also the message from them. And in this memory, we use the shared Empty key, which can be read and write from the ARM processor and FPGA part at the same time. And we also use the ARM to load the initial data from some machine code to the memory. And we also send the clock, reset, these control signals from our processor to the FPGA parts.
Mm-hmm.
Yeah. And we can choose some simple programs.
Okay.
Yeah, currently when we run the program, it will ask us to choose the program name of the assembly.
Mm-hmm.
For example, we run the assembly AND.
Maybe we can show the assembly.
Oh, the assembly. Okay. The add in. So this is the assembly code.
Yeah, it's a simple program which consists of a few number of instructions. And first, some CSR instruction to initialize the register file and then add instruction.
And it will be converted to the hex file.
And how do you compile it?
Use the Python code
Python
provided.
Script to assembling our instruction to this machine codes.
Okay.
And we can then load these codes into the memory from the ARM.
Sure. Okay.
And on the ARM side, at first it starts reading the fields, reading the hex fields, and starts the initialization of the instruction memory, the data memory, and the sink memory, and the source memory. And then it will print out the line trace of the whole processing procedure of the each stages on the processor.
Mm-hmm.
And then in each cycle?
In each cycle. And when the processor is done, it will dump all the memory to check the content of it to see if they are matched.
Match with our expectation.
Mm-hmm.
Yeah. And finally, it will display the total cycles that it spends on the program, and it will compare the actual value of the red fields with our expected value.
Okay.
Yeah, shown here.
And show if it is passed.
Yeah, and
that's a simple add program, and we also tested some branch jump, and we can also show.
So am I correct that you're comparing the contents of the sync memory with the test memory? Did I understand that correctly?
Yeah.
Okay.
and we can run another assembly program like this one.
This is big.
Yeah, it's a branch. And when two values are equal, are the same, then it can jump to the specific instruction position.
Okay.
And it also works. then we design a visualization method to show some complex algorithm that can be run on this processor.
Okay.
So we'll show you this three. The insertion sort, the insertion sort,
Insertion sort?
and bubble sort, and then selection sort.
Okay.
Use three number sorts algorithms, and you can
Yeah, we will run right now.
first
Insertion sort.
You can see this VG screen.
Oh, look at that. Just get closer.
The left part is a number.
The value, and the right is the color.
Yeah, the larger the number, the brighter the color.
And when it finishes,
Neat.
And each row corresponds to one position in the memory. And the first line is the memory position 0, and the bottom line is the memory position 9.
Okay.
And we only use 10 values because it's more suitable to show on the VGA. And what we just shown is the insertion sort, and we also
We can change the algorithm to do the same thing. For example, the bubble
bubble
sort.
sort. As it compare two of each, and put the largest number to the bottom.
Yes.
The second largest, and then the third largest. Compare two of each.
So you've implemented this processor on the FPGA,
Yeah.
and then am I correct that when you select a particular assembler program there, the compiled hex file gets loaded into on-chip memory,
Yeah.
and then it'll start
the
executing the program? Really interesting. Okay.
And also the last is the selection. So if you go from the top to bottom, find this, the smallest one and put it here. And
Okay.
then,
second as well.
the second smallest put here. The third smallest, fourth smallest.
Neat.
And this one.
Very nice. Cool. Awesome. Thank you. That's really cool.